Haptic texture rendering is a process of reproducing contact responses based on the haptic texture model of the surface. During tool-surface interaction, this feedback is in form of vibrations that propagate through the tool. There are two classes of homogeneous haptic textures, isotropic and anisotropic. Isotropic haptic textures have similar vibration responses regardless the direction of the tool movement. This research is focused on the anisotropic haptic texture rendering, where the vibration pattern is changed with respect to the movement direction. The haptic texture model is built from the data that are collected by a special recording apparatus during an unconstrained tool-surface interaction. These data are segmented into stationary acceleration patterns of the contact vibrations using a bottom-up approach in such a way, so the movement trajectory of the tool remains in a straight line, with a nearly constant velocity magnitude and normal force per each segment. A set of input vectors and corresponding set of acceleration patterns are computed based on resultant segments, where the acceleration patterns are converted to line spectral frequency coefficients and the input vector is determined by a mean velocity vector and mean normal force. The radial basis function neural network is trained using the resultant input-output pairs. This network is referred to as haptic texture model, which interpolates contact acceleration patterns based on an arbitrary input. In this work we developed a cross-platform computing library that renders contact vibrations of anisotropic haptic textures. The acceleration pattern is calculated based on the input by the haptic texture model 100 Hz and stored inside the buffer in form of LSF coefficients. The output acceleration value of vibrations is estimated 2 kHz. 8 anisotropic and 1 isotropic haptic texture models are built and deployed to the tablet PC-based rendering setup. We offer two demonstration scenarios that will show the rendering quality of the virtual anisotropic haptic textures to the audience. First scenario is a simple exploration of virtual and real surfaces. After exploration of each real virtual pair, the participant is asked to give a feedback about the realism of rendered textures. The second demonstration scenario is a matching test. The participant explores a grid of virtual samples, where image textures are hidden. The participant is asked to find a corresponding virtual pair for each real sample. When the task is finished, image textures of samples are displayed and the number of matching pairs can be counted.